In the previous video, we understood the meaning of a function, the meaning of a relation, and we were recognizing when a function can be a relation and when a relation is distinctly a function. A function is a formula in which for every input there is a distinct one and only one output. But a relation can be a function. But in a relation, a particular input may have more than one output. That is how we distinguished between a function and relation. In this video, we will identify the family members of function. This would mean what are the types of functions that we will understand and we'll identify them. If mathematicians are cooks, then families of functions are their ingredients. So we need these family of functions, and basically these family of functions are those formulas where an input x, the x value is inputted, means substituted, and we get a distinct output. So what are the family members of function? So we have identity function. What is the meaning of identity function? Identity function means fx is x, means y is equal to x. So we can find coordinates for this, like for a particular value of x, you will have a distinct value of y, like x0, y is also 0. So 0, 0 is a coordinate. When x is 1, y is also 1. When x is -1, y is also -1. So plotting those points and connecting those dots, we get a straight line graph. So this kind of a graph is the graph of identity function or graph of the function fx, which is equal to x, and fx itself is y. Y is the range set element and x is the domain set element. Next one is a squaring function. So basically fx is x square. This is a quadratic equation graph. Standard form ax square plus bx plus c. So a quadratic equation is something which has got this term that also can be called as a quadratic equation. So here the function fx means the function is in terms of x, which is basically y is equal to ax square. So we can think of different values of x. On substituting that, we can calculate and get the corresponding value of y, like fx, which is y, is equal to ax square. So in place of x, you take 0, y is also going to be 0. So 0, 0 is one of the root solution or 0 of this function. When x is 1, y is also, let's take a as something. So y is going to be 2 times 1, that's 2. So 1, 2 is the coordinate. So we can have 1, 2. Like we can create those coordinates. And with those coordinates, when we connect, we get a parabolic function. So this is a parabolic function. Parabola. Parabola is basically, we get it for a quadratic equation graph or a squaring function. Then cubic function. Cubic function is something in with exponent or power 3. So for distinct values of x, we can get the corresponding value of fx, which is y. Those y values we will have on the vertical line and x values we'll have on the horizontal line. Value of x will be called as a 0 of the equation. Rest every other point on the graph is a root or solution. But those distinct, that point where the graph intersects x-axis is exclusively called as 0 of the function, because for that particular value of x, y turns 0. That point will be on y-axis. So cubic function will be like this or like this or like this. And the cubic function will have minimum 1 0 to maximum 3 zeros. Next, square root function. How does square root function look like? Once we plot all these points, when we like fx is basically y and square root of x. So we can create a tabulation where we can find the coordinates that will help us to plot the graph or draw the graph. Plot the points and draw the graph. I mean that. So let's see. Let's find few points. So that's x and that's a y. Y is a square root of x. So let's take those values of x whose square root we can easily find. So basically composite numbers. So when x is 0, y is square root of 0, that is 0. So first we are going to look at 0, 0. So that means square root function y is equal to square root of x has one solution or 0 or a root that is 0, 0. Next, when x is 4, y is a square root of 4, which is 2. So we can search for 4, 2. So here we go. For 4, there is a 2. This is that coordinate. 4 of x-axis, 2 of y-axis. So we can even try for, we can't go for negative because square root of negative numbers are not possible. That's why this will be in the positive direction only. So when x is 1, y is also 1. So x is 1, y is 1. This is another point. Let's take 2 also. X as 2, y square root of 2. Square root of 2 is 1.414. So let's do that approximately. See, 2 corresponds to somewhere between 1 and 2, but not much in the middle point. So this is that. So when we connect these coordinates, means these dots, 1, 2, 3, 4, we get a curve. So square root function curve will be like this. So we introduced ourselves to the square root function. Square root function graph will look like this. Here we go. Reciprocal function. How does the graph of reciprocal function look like? The reciprocal function is also known as a hyperbola or a rational function because it is in form of p by q and the graph is hyperbolic. So this is parabola and this one is a hyperbola. It has two parts that are disconnected and is not defined at 0 because if x turns 0, 1 upon 0 is an undefined term, means not defined term. So how does the graph of a reciprocal function look like? Like fx means y is 1 upon x. We can try plotting the graph. I just quickly do this, that x and then we have y which is 1 upon x. So when x is 0, y is not defined. That means we don't have a point at origin. See, the graph did not meet at origin at all. When x is 1, y is 1. See, the distinct point you can clearly see here. When x is negative 1, y is also negative 1. See, we have that distinct point also here on the graph. X is 2, y is 1 upon 2, means what? 0.5, 2 comma 0.5. 2 is connected to 0.5, see? This point is 2 comma 0.5. X is negative 2, negative 0.5, negative 0, negative 2, negative 0.5. This is that point. This is that point. So likewise, for a distinct value of x, we will get distinct. For particular value of x, we'll get distinct value of y on substituting the value of x and solving it. And the graph is a reciprocal function. So this is a very beautiful graph, which never meets x-axis as well as y-axis, not origin also. Next, power function. So power function is, that was fx, the earlier one what we saw is a reciprocal function, 1 upon x, x to the power something. But this is called power function. Power function is exponential function and logarithmic functions are the power function. Exponential function is e to the power 1x, 2x. So likewise, the graph will tend to go as close as x-axis, but it never comes closer to x-axis. And here, if x is 0, so e to the power 0 is 1. That's why it crosses, like its y-intercept is 1, and it is a rising curve. Exponential functions are, so e to the power x is this. E to the power negative x will be something like this. So these are exponential functions are symmetrical about y-axis, whereas logarithmic functions are symmetrical about x-axis. So the graph will be the one that you see, or it will be like this. So log functions are symmetrical about x-axis. Exponential functions are symmetrical about y-axis. So wonderful family of functions. We also have functions like periodic function family, sine, cos, tan, all the trigonometric ratio functions, they are periodic function. So sine goes the way you see, from origin maximum up to 1 like that. Cos graph comes like this. So these are periodic. So tan goes like this. So they are all periodic functions. Absolute value function. Absolute value function is fx if we take it as y, and that is the modulus of x. So in place of x, you take positive values, 0, negative values. So you can have positive values of x, negative value of x, even 0. But whatever, y is going to be the positive number. Why? Because absolute value of any number is always a positive number. That's why the graph is symmetrical about y-axis, and it is a straight line graph because however it is still linear equation. So periodic function graph, periodic function and absolute value function are also family members of function. So we have seen many types of functions, and the whole lot of mathematics is around these functions. Moving ahead to logistic function. Logistic function is an expression of this kind where the graph tends to go as close as x-axis and has a y-intercept and then proceeds. This is logistic function. Now, let's do a little bit of understanding, like what we have studied. We have seen so many types of functions. Now, let's sketch a graph of the function from memory. We have seen all of them. Let's remember how the graph used to be. How does exponent function look like? Exponent function is a graph that is symmetrical about y-axis. E to the power x will be the right side one. E to the power negative x will be the left side one. How does graph of logarithmic function look like? These will be something that will be symmetrical about x-axis, like this. And their steepness increases if the coefficient is a number that increases. There are many other things, like how they move about x-axis or y-axis. Y is equal to sine x is a periodic function, so the graph is periodic. X square, y is equal to x square is a parabolic function. So the parabola can intersect x-axis in two distinct points or just in a point, or it may not meet a point, but it still stays a parabola. Fifth one, absolute function graph. Absolute function graph means what? Whatever be the value of x, positive, negative, 0, but y is going to be positive and the graph is symmetrical about y-axis. Y is equal to 1 by x is reciprocal function. Reciprocal function graphs are very interesting. Reciprocal function graphs are graphs which never touch x-axis, and they have a disconnect also, like this they go. Seventh one is a logistic that starts from as near as negative x-axis, has a y-intercept and proceeds. Square root function. Square root function was very interesting. We have seen square root function that it goes like this. It will never come in the negative y, because a negative x. It will never come in negative x, because square root of negative number is not possible. Cubic function. Cubic function means the graph will definitely intersect x-axis in 1 point or 2 point or a maximum of 3 point, but not beyond that. Last one is y is equal to x. That is called the identity function. Identity function was a graph that passes through the origin and which is neither parallel to x-axis nor parallel to y-axis. So that was a wonderful exercise that we just now did when we identified the function, and most interesting part is we identified the function through the graphs. Understanding things through the graphs is really interesting. Now, in case you want to do more work on this, here is a set of questions. Definitely enjoy answering them. I hope this video is useful.